status functions that we have. And in here, just keep in mind that these 5 status functions are something that we assume. But in reality, in all the processes that you want to study, you have to be careful about what are the components that are necessary for your system to run correctly. And then get these 5, which is the status function. So what it really says is that if 5 components in your system, which meaning that all the components working correctly, your system would work perfect. The second one is showing that if the first 4 components are working, your system's gonna work. This one is showing that if just component 1 and 2 work well, then your system is not working. So after getting these possibilities, we can move to path vectors and cut vectors. Who remembers what was path vector?
Just the ones to zeros.
Yes. So all the vectors that the status function is equal to 1. So after getting those, we have to calculate the minimum path vectors. So we are going to get these vectors, component vectors, and we are going to reduce all of these ones to 0 and see what's the status function would be. So if we reduce all the ones to 0 and all of the reduced vectors have status function equal to 0, then we can decide that it's the minimal possible thing that our system is going to work. So let's take this example. So we reduced all of the ones to 0, one by one. Here, one of the reduced vector, the status function is equal to 1. So we cannot conclude that this is minimum path vector. But in the second example, we reduce all of the components from 1 to 0, and all the status functions are 0. Okay, so we can conclude that it is a minimum path. So following the same method, we can get all the minimum path vectors, which are vectors having 0 ones. So we are gonna relate them to the components that we have in the system. So for example, the first minimum path vector is 1, 0, 0, 1, 0. It means that first component and fourth component should work in your system properly, and this is the minimum path setback. Okay, am I moving too fast? Or is that okay? Pace? It's okay. So, after getting all the minimum path vectors, we are gonna draw the equivalent structure. So, the minimum path sets, we had component 1 and 4 together, 2 and 5, 1, 3, 5, 2 and 3 and 4. So what we're gonna do is to draw them all in series and make the whole system as in parallel. So it's gonna be the equivalent structure for the minimum path. Let's move to minimum cut vectors. So cut vectors were the vectors that the status function was equal to 0. If we are going to change all the zeros in the vector to 1 by 1, and the status function would be 1 for all of those, then we can conclude that it's a cut vector, right? So it's telling us that in our system, what kind of combination I could get and just change a little bit in that system to get my system changed to working condition. So if we have this example and we change zeros to ones 1 by 1, for this one, changing one of the zeros to 1 doesn't lead to a working system. But in here, in the second example, all of them would be 1, and we can conclude that it's a cut vector.
The third vector from the bottom is wrong.
This one? Yeah, it should be 1. That's a typo. Sorry. Okay, so exactly the same as what we told. We are gonna get the minimum cut sets, and the difference between minimum path and minimum cut is that first, for each minimum cut sets, we have to put them in parallel and then make them in series. Right. So this is going to be the balance structure. What we can get from this one is that if we want to begin from here and finish this system right here, we can see that, for example, if component 1 and 4 is working, then 1, 4, 1, 4, that whole system would work, which is in consistence with what we got from path vectors, right? Because in the first row, you can see that we have a parallel structure. So if we go from the first row, we have 1 and 4 working, and the whole system works. So we can check it by all the combinations that we have. This is another example, but the lunch is ready, so you can go and grab your lunch, and then we can go through this.
Decided right now. It's road